Hello everyone, today we're going to do some configuration of GRE or just making some tunnels or precursor for VPNs actually. Now then, what's a prerequisite for creating your own tunnel? You must already have the topology of your network connected to each other. In our case, we're using router EIGRP 100 and this is our topology. So show IP interface brief, yep, and show IP interface brief. I already put the tunnel there. Let me remove that. Now interface tunnel 0. That's how you remove the tunnel, by the way. There it is. IP interface brief. Show IP interface brief. So ready. Now we're going to test out our network topology by ping our ping RT to R4. We're going to ping RT from R4, so we're going to ping 192.168.2.2. As you can see, these are the 192.168.1 network, whereas this is .2 and this is .1. Same, we have 200.0.0.0 network with a network subnet mask of /30. These are .1 and .2. Our cloud is only a simulation from Cisco 7200 ISO. It still works actually. This is our 200.0.1.0/30 network sub, and then 192.168.2.0 network subnet of 24, and .1 and .2 for our routers. So let's start pinging, and I'm going to show you the after effects in our Wireshark. So ping, and then let's show you what happens in our Wireshark. So as you can see, our source, which is 192.168.1.2, is asking for a reply via ICMP to 192.168.2.2, which is our request, and then .2 replied, and request and reply. This is the first ping, the second ping, the third ping, the fourth ping. So basically it worked. And also you can see here the EIGRP, because EIGRP is constantly asking for any updates throughout the network. So those are those yellow things. So let's check the frames. So interface ID, the encapsulation data type is Ethernet. And you can see that. The frame length, how long is it? So this is basically you checking if it's really ping or how big the data that's sent, for checking for hackers or payloads and such. Our protocols and frame is Ether type, IP, we send ICMP, and what type is that data? So string ICMP with Ethernet 2. Here you can see the destination and address, the source and the address. Destination length, different flag reserved, and internet control message. We send a ping request. Checksum status good. There's no problem whatsoever. Nothing interesting. So we made the reference. So now we're going to start configuring until now. Then let's turn back to our topology. There you can see it. Okay. So I decided to put a tunnel between R1 and R2. Now remember, treat tunnels as virtual interfaces, which means that how you're going to configure tunnels, it's the same way you're going to configure physical interfaces with a little difference. So just like in interfaces, you're going to put interface tunnel and then its number. But in our case, it's a virtual interface, so it's a lot bigger. Now, what do you do when configuring interfaces? You add some IP addresses. Now, I've chosen this one. This is R1, so this is 255.255.5.252 or /30, meaning there's only 2 hosts I can use because, well, if you're going to use GRE, you might be only using 2 hosts to connect, which is site to site. So definitely better. But if you're going to use other IP addresses for security purposes to make it harder for the hackers or packet tracers to trace which IP you are going to use, then be my guest. Use /2 or /3 or whatever. So just in physical interface, we're going to no shut it. Now do show IP interface brief. Check what happened. Yep. So we've successfully put our IP address here. We have manually up it, but its protocol is still down because we need to configure both of them so that the protocol goes up. By the way, GRE is stateless. Therefore, you don't have any real way to check what's the problem between the other interface because it doesn't record any data, but the only way to know that it's working if it's, well, up or work. So that's that. Now then, oh yeah. Second, the next part is adding a tunnel source. Now remember that we are using tunnels which are virtual interfaces. The data is still actually being routed or sent through our physical interfaces, in which case we're going to use this gigabit 1/0. Now you can use IP addresses or interfaces, but for simplicity's sake, you're going to use that one. Actually, I'm going to check if you need something masked. I don't know. Tunnel source destination of 10.0.0.2, and that's about it. We're going to configure the R2 interface tunnel 0. We're going to no shut it and add an IP address of 10.0.2.
Because sometimes what you really need is for someone else to pay a horrible price.
Oh yeah, I made a mistake by the way. See, I've told you that we're going to use the physical interfaces because we're going to send it there. But instead, I've used the IP addresses of our tunnel. This won't work because it's in virtual. It's not actually connected to each other. That 1.2. Destination, yep. Okay, now see this? We've just turned our interface tunnel 0 up. We're going to do the same as this one. That's 2. Too much. That's 0.2, and there we have it. Now I still shouldn't be able to ping it probably. Yeah, sorry. I should not be able to ping this. But let's check that one. It should fail because we haven't put the other stuff yet. It failed. Let's see, Wireshark. As you can see here, the red ones. We've tried to ping from R4 to 10.0.0.2 or R1, R2 actually. It failed because we haven't actually made an ERGRP yet, or we haven't actually routed the interfaces. Now, if you can see here, like I've told you, tunnels are virtual interfaces. They're not actually connected via physical cables, so they don't automatically get the static or the direct routing. So we're going to have to route them. Now we can use static routing, or in my case, I just want to add router EI100. Wait, I'm gonna exit this and should router. Yeah, I'm just going to add this into our ERGP network. It's network of 10.0.0. This is the old way of configuring ERGP. Usually you will use the wildcard mask. Oh, what's 252 minus is 3, right? But we're going to use the old way. This is faster. And same with here. 100 the network of this should be up now. Yep, see, show EIGRP question mark auto show IP routes. We have already here. We have 2 subnets and 2 masks. That should be right, and we should be able to ping that one. Yep, we have successfully pinged our tunnel interfaces, which means our GRE is up. Now, since GRE only encapsulates data, we should be able to see it here. So as you can see there, we're going to check. So and our encapsulation is still. So these are source 10.0.1. Destination is here. Oh, this is here, damn. These are source R4, and we are going to ping destination 10.0.0.1 via ICMP. See the difference. Encapsulation still is Ethernet, time shift. Yep. Here we have. We have protocols inside the frame. Is we have Ethernet type. We have then IP, then GRE. So we encapsulate IP, CMT, and data in GRE. This is why you aren't exactly protecting your payload or data, but you are covering up your capsule or header frames. So you're hiding them. It's a one-way using. So destination address still the same. There's nothing different. Internet protocols though. So it's source 200.0.1.2, destination is 200.0.0.2. So it's not actually saying now that it came from 192.168.2.2. In fact, it shows here, but it's not showing here. We hid it. It doesn't know it doesn't know the original, but it does know from which router, which is this one. From which router, we're going to change from. It doesn't show that this is the one that's sending. It shows that this is the one that's sending it. So basically, if this is your VPN provider, it shows that this is the one sending the data. So essentially hiding you, except if the router or if the packet tracer is inside the network of your VPN provider. But still, GRE doesn't hide your data actually. If it found out that, oh, there's something weird about this, then you can still see it. So differentiation, identification, we've added some protocol generic routing encapsulation. You can see that they know, the packet tracer knows that this is GRE. Validation disabled, header channel. The source, see, it's 200.0.1.2. Source GOIP is unknown. The destination is unknown as well. So basically, if the router, the cloud doesn't know from which it came from, without further investigation. So see, yep. It's useful for if you're trying to learn VPNs, which I will be making another discussion. So here we can see the source is 192.168.2.2 and destination is 10.0.1.1. Now we can only see this since we are using packet tracer, but the router doesn't. It just sees the first layer or the first encapsulation. Ping, yeah, there's nothing, no response since. And there we have it. That's why it's quite important to use packet tracer in your company. And this is also why VPNs is quite useful for hiding data or hiding where you've been, what IP. Since it takes a lot of work, or if there is no security configuration set that bans these protocols, then you would be able to go through it easily. Now, if you can't use GRE, definitely your ISP is blocking that protocol. You can absolutely do that. So that's about it, and thank you. Goodbye. Stay tuned and subscribe because I'm going to use some VPNs or IPsec in our next video.